In this video, we're going to talk about a couple of trends on the good old periodic table. This, you'll notice, is your Part 1 notes from chemistry. So first of all, the major groups of atoms that exist here. In Group 1, we have the alkali metals that react strongly with water to produce hydrogen and a lot of heat. We did this by putting some sodium in water in class. You've got the alkaline earth metals in Group 2. We burned some magnesium in air, forming magnesium oxide. These react slightly with water and also with acids to produce hydrogen. You've got transition metals in the middle. These are pretty much your standard metals. You've got nickel and silver and gold and copper and manganese, chromium, anything that you think of as a metal, hard, shiny, ductile, malleable, things right in there. Down on the bottom, you've got the inner transition metals, which remember would fit in right here, but it would make the periodic table really long, so we kind of take them out and put them down there. A lot of them are radioactive. They have some interesting patterns with their electrons. We didn't talk much about them in class this year. You've got some other metals right here. They've got kind of interesting properties. Aluminum, for example, is a metal, clearly. It's shiny, but it's got some interesting properties. Lead is very heavy, and tin is very soft, as well as lead. So they're metals, but they're a little bit different. Anything touching the stair step, and the stair step, remember, is this line right here, going right down there, with at least two sides, is considered a semi-metal. They're sometimes conductors, they're sometimes not. They have properties of metals and properties of non-metals sometimes, depending on their particular situation. These are the non-metals in here, so carbon, nitrogen, all these halogens in group 17 as well. Remember, the halogens right here are called halogens, halo meaning salt, because they can make salts. You combine a halogen with a metal, and you get yourself a salt. So like sodium chloride would be your classic salt there. You could also do potassium bromide or strontium iodide or whatever you wanted to do. Lastly are the noble gases right over here. They're snooty. They don't combine with anything. They've got all the electrons in their outer ring that they want. A couple of patterns you should note. Ionization energy is highest over here and lowest over here. This is it takes the most energy to remove an electron from the outer ring. These really like to hold on to their electrons. Related to that is electronegativity. You'll notice the patterns are very similar because these atoms love their electrons. These don't really care. In fact, these ones in group 1 will readily give up their electrons, just like sodium, because it has one extra that it doesn't really want. In group 17 over here, the halogens, fluorine wants one more, so it will gladly take it. These love their electrons, these not so much. Atomic radius is a little counterintuitive. As you go this way and down, you get the biggest atoms. Remember, over here, sure, they have the most protons, but that also means that they've got the biggest nuclear charge, most positive charges in the nucleus, and they're pulling their electrons really tight. These ones have a lot of neutrons, but not as many as these, so they don't pull their electrons in as tight, makes for bigger atoms. And then as you go down in this direction, you get things that are more metally and things that are not quite so metally up there. So please make sure you're aware of all these atomic characteristics on the periodic table.